Hello all, my name is S. Jawahar Reddy. I am from Information Technology branch and from the College Institute of Aeronautical Engineering. And today my concept is about polyurethane. So let's discuss points about preparation and the applications of polyurethane in our daily life. So let's dive into today's concept. So, what is polyurethane? Let's know what is polyurethane. Polyurethane, often abbreviated to PU or PUR, is an organic polymer. It is an organic polymer that features many organic units linked via urethane molecules. Most polyurethane do not melt upon heating and can therefore be classified as thermosetting polymers like bakelite, etc. However, it can be noted that some specific types of polyurethanes exhibit thermoplastic properties and can be melted and remolded via the application of heat. Primary application of polyurethanes is in production of foam seating material. This is what is about polyurethane. So, it is used in production of foam seating materials that offers high resilience. They are almost used in microcellular foam gaskets and seals. These are used in microcellular foam gaskets and seals, rigid foam insulation panels that are rigid foam insulation panels and spray foam. It can also be noted that this class of polymers is also employed for the manufacture of certain elastomeric tires and wheels. These polyurethanes are also used in uh, construction of houses where it is used to in winter it is used to uh, resist the heat inside the house, and in summer it sends the heat inside the house to outside. It is used like that. So uh, and such as those shopping carts, it is also used in skating boards and roller coasters. Polyurethanes are also used in some high performance adhesives, means like Fevicol, etc. So let us know about application of polyurethane. Some important applications of polyurethane are listed below. Primary application of polyurethane is the production of foams. As we discussed earlier, it is used in production of foams. These foams are used in a variety of materials such as upholstery fabrics, domestic furniture, and refrigerator sheets. We can see this foam in refrigerators, where, which is useful to resist the cold inside. Polyurethane is also used in some garments. Polyurethane moldings are also used in columns and door frames. We use them in door frames and some columns. In fact, it is not uncommon for such moldings to be employed in window headers and balusters. The low-density foams of polyurethane, which exhibits flexibility, are widely used in mattresses and other forms of bedding. They are also used in automobile seats and upholstery. Flexible polyurethane is also used in the manufacture of partially elastic straps and bands. The low-density elastomers of polyurethane are widely used in the footwear industry. low density elastomers of polyurethane are widely used in footwear industry. Flexible polyurethane is also used in manufacture of partial elastic straps and bands. Low density forms of polyurethane which exhibit flexibility are widely used in mattresses and other forms of bedding. Another notable application of polyurethane is in the manufacture of bathroom and kitchen sponges. It is also used in seat cushions and couches. So, composition and preparation of polyurethane. Polyurethanes, along with phenolics, epoxies, and unsaturated polyesters, can be classified as reaction polymers. They can be prepared via the chemical reactions between isocyanates that contain two re- at least two isocyanate groups per molecule and polyols that contain at least two hydroxide groups per molecule. These reactions usually require the presence of a catalyst or some ultraviolet light in order to overcome the activation energy barrier. Polyols by themselves can also be considered as polymers. For example, polyether polyols can be prepared by subjecting propylene oxide and ethylene oxide to copolymerization along with an appropriate polyol precursor. It can also be noted that the preparation of polyester polyols is quite similar to that of polyether polyols. However, for the production of polyurethanes, the chain length of the polyol and the functionality of the polyol must be controlled. These factors are known to contribute to the properties of the final polyurethane products. For example, the polyols whose molecular weights lie in the hundreds yield rigid polyurethanes, whereas the polyols whose molecular weight lie in the thousands yield relatively flexible polyurethanes. Thus, the chain length of the polyol used can be considered as a factor that contributes to the flexibility of the polyurethane product. So, properties of polyurethane are the properties of polyurethanes are highly dependent on the manner in which they are produced. These are dependent on the production. For example, if the polyol chain, which is used as a raw material for the preparation of the polyurethane, is long and flexible, the final product will be soft and elastic. On the other hand, if the extent of cross-linking is very high, the final polyurethane product will be tough and rigid. The cross-linked structure of polyurethanes generally consists of three-dimensional networks which attribute very high molecular weights to the polymer. This structure also accounts for the thermosetting nature of the polymer, since polyurethanes typically does not soften or melt when exposed to heat. Polyurethanes have the ability to be made into foams, which is one of their most desirable properties. This is done by facilitating the production of a gas, usually carbon dioxide, is produced during the urethane polymerization process. Another advantage of polyurethane is that high density microcellular forms of polymer can be produced without any glowing agents. Thank you. This is all about polyurethanes, polyurethane preparation, polyurethane applications, and and the properties of polyurethanes.